At its most basic, disaster recovery for VMware is about copying files. While a Windows operating system can be composed of hundreds of thousands of files, a virtual machine consists of just a few files that are usually encapsulated to a single file or folder. Of those, only the disks, which are known as VMDKs, and the registration, which is known as a VMX file, are actually required to reproduce the virtual machine. Once the files have been replicated from the production site, sometimes known as the protected site, to the DR site, theoretically, you have a viable virtual machine replica. It's not quite so simple, though. Virtual machines are composed of very different types of data, and no two VMs are alike. In most cases, the active data and largest delta created by any VM is in its paging file or swap partition. Ironically, in most cases, paging data does not need to be replicated as part of your DR plan. What you really want to replicate are any change blocks in the VM except the paging file, especially the hot data that represents ongoing work product. Some types of DR solution rely on Sandbased Replication. Sandbased Replication looks at the LUN and has no insight into virtual disks. Because these devices see only data that's been changed at a block level, not only is paging data replicated, but quite often all a user needs to do is access a file in order for the property NTFS last access update to be set, potentially marking that data as changed as well. This is particularly problematic for large databases and GIS libraries and things like that. Anytime somebody looks at a PDF file, anytime somebody looks at an image, it gets marked as change data even though it's not, and then the SAN has to replicate it. Right? You can look up NTFS last access update and learn how to, or all of the strategies associated with dealing with that. But it's definitely a downside to relying on your SAN to replicate from your production site to your DR site. Moreover, SANs typically rely on external compression and deduplication technologies like those by Riverbed in order to get efficient replication from source to destination over the VPN or MPLS connection that you have in place, even dark fiber between your production or protected site and your DR or recovery site. So SAN-based replication is great, but it has some limitations. Veeam works at the hypervisor level, either ESXi or Hyper-V, and has direct insight to the virtual machines and disks being replicated. Not only is it possible to omit paging data, but compression and deduplication are included by default. And a built-in WAN accelerator is available in Veeam Backup and Replication Enterprise. What we've done here is we've drawn a model where we've got paging data represented in red, OS data represented in blue, and hot user data represented in green, and we're trying to illustrate the potential difference between the amount of data that needs to be replicated with SAN-based replication, of data that needs to be replicated using a hypervisor-based product like Veeam that has insight into the virtual machine itself. So there's a tremendous savings in the amount of data that goes over the wire when you're using a hypervisor product like Veeam.